Good morning, everybody, and welcome to our Pre-Calculus 40th class. So today what we're going to do is we're going to continue on with the topic that we started last week on Friday on solving trigonometric equations. Um, Today what we're going to do is we're going to talk about the multiple angle and also the quadratic trig equations. So let's get started on this particular case. Um, I just want to start with this part here. So sine of 3 theta. So the the b here is 3, and then theta is the angle that we're looking for. So 3 times the angle. When we look at this particular case, in terms of a transformation point of view, we could actually say that here the period is decreased, and because of that it is this is going to be stretched, no sorry compressed by a factor of 1/3. So it's going to be compressed. Now if it's compressed, there's going to be a lot more waves within the span of 2 pi. So how do we do that? Let's see here. What we're going to do is I'm actually going to solve it for this 0 to 2 pi, and then I'm actually going to write down the general solution for this for any values for theta. So let's get started. What we're going to do is we're going to look at this as a whole. So instead of sine of 3 theta is equals to root 3 over 2, we're going to let x is equals to 3 theta. So we're taking all of these and we're going to put x right there. So now the new equation would look like sine x is equals to root 3 over 2. Now this one here, root 3 over 2 for sine of x, we will recognize, hey, that is a special angle. And where is sine positive? Sine of x is positive in quadrants 1 and quadrant 2. And this is a specific angle. It's a special angle. So when we look at that one, root 3 over 2, sine of root 3 over 2 is going to be right there. It's going to be right there. So it's going to be at pi by 3 right here in quadrant 1, and in quadrant 2 it's going to be 2 pi by 3. So in quadrant 1 it's going to be x is equal to pi by 3, and in quadrant 2 it's going to be x is equals to 2 pi by 3. Now, the situation here is that we are really not solving for x. We are solving for theta. So what we're going to do is replace the 3 theta back. So now put the 3 theta back. So instead of x, we're going to replace x by 3 theta back again. Okay, so it would look like this. 3 theta is equals to pi by 3. Now let's solve for theta. Okay, we'll divide by both sides by 3. So therefore theta is equals to pi by 3. Okay, times 3. Okay, I'll just skip that step. I'll just go pi by 9. So theta has to be pi by 9. Now what about this one? We're going to replace the x by 3 theta again. So it's going to look like this. 3 theta is equals to 2 pi by 3. And then divide both sides of the equation by 3. So theta is equals to 2 pi by 9. So now, because it's 3 theta, theta is pi by 9, and the other one is 2 pi by 9. 2 pi by 9. These are the two solutions. Is that going to be the solution in this particular domain? So the domain for theta is going to be between 0 and 2 pi. And pi by 9 is going to be between 0 and 2 pi. And so was 2 pi by 9. 2 pi by 9 is also within 2 pi, 0 and 2 pi. Now, if we were to write down, because I know I'm looking at the textbook and the questions from the book, the question is, what are the general solutions? So if there is no restriction in the domain, what are the all possible solution? So if we want to do the general solution, okay, need the general solution. Okay, so remember that this is going to be all of the solutions will be the coterminals of pi by 9. So what are the coterminals? The cycle happens normally, the cycle goes to 2 pi, goes around every 2 pi. But this particular case, because this is a horizontally compression by a factor of 3, then there's going to be more possible solutions in here. So what I'm trying to say is that the period will change. The new period, we said period is equals to 2 pi over b. And then we look at our equation in here. Well, the b is 3. So 2 pi by 3. So that's the new period. So therefore, the general solution, therefore, erase this piece. The general solutions are pi by 9 plus 2 pi by 3 times k, where k is an element of an integer. And for this part here, all of the possible coterminals for that would be 2 pi by 9 plus 2 pi by 3. Okay, remember the 2 pi by 3 is because the period has now changed for this, this equation. So it's going to be 2 pi by 3 times k, where k is an element of the integer. Okay, so that's that part. Now, just like what we did before, what we're going to do is we're going to check our answer. Let's do a check. I'm going to try to squeeze it in here. I'm going to do a check. Let's see if I can do that. We're going to check our solution, and we're going to check pi by 3. Okay, so if this is an equation, the left side has to equal and balance the right side. So what does the left side look like? Well, the left side looks like sine of 3 times theta, and theta is pi by 3. So that's what the left side looks like. And what does the right side look like? Right side is equal to root 3 over 2. Okay, so after we figure this out, if our answer is correct, indeed correct, then it's going to be, oh no, so this is pi by 9. Going back to this one, sorry, this is pi by 9. Yeah, that's pi by 9. Pi by 9. If I work this out, it should equal to this one. Okay, so let's give it a try. So sine of 3 times pi by 9. Okay, well, that 3 and the 9 cancels each other out. So I'm going to have sine of pi by 3. Okay, well, what is the sine of pi by 3? The sine of pi by 3 is root 3 over 2. So the left side is root 3 over 2. The right side is root 3 over 2. So that means the left side is equals to the right side. So that's a good solution. It's correct. Now, what about this one here? What if our answer is 2 pi by 9? So let's give it a try. Check. 2 pi by 9. So again, the left side, we're going to verify our solution. Verify. Verify, that means to check if it is correct. So the left side looks like this. So sine of 3 times 2 pi by 9. So 2 pi by 9. And then it should equal to root 3 over 2. So let's verify that it is true. So 3 times 2 pi by 9. So the 3's would cancel. So we got 3 in there. So sine of 2 pi by 3. Well, what's sine of 2 pi by 3? Sine of 2 pi by 3 is root 3 over 2. And then this is going to be root 3 over 2. So it is correct. Okay, I'm just going to move this over because it's getting really, really squished in here. Okay, I just want to make sure that it's whoever reading this is able to read it. Root 3 over 2, and then this one is root 3 over 2, which is correct. I'll just put the other solution in here. 2 pi by 9 plus 2 pi by 3 k, where k is an element of integer. K, where k is an element of integer here. Okay, so everything that we've done so far, starting in chapter 6, are coming along here with the coterminals, the period, the solutions, and so on, and the unit circle. So it's pretty like intense information that we have to figure out. So that's that part there. Okay, I just added this piece. This piece is added because some of the questions in the book has this. Okay, now let's take a look at letter B. Example 5, question B. Solve the equation for 3 cos of 1/2 x minus root of 2 equals to 5 cos 1/2 of x. Okay, I gotta pay attention in here. The domain is stated in degrees. Okay, so the domain, we're looking for x, where x is in degrees in here. So what can we do? What can we do? Here, just to kind of think about this, the cos of 1/2 x. So think about our the function that we just talked about in last unit. You said cos of 1/2 x. So the b value is 1/2. So that means the period, or horizontally, so that's basically horizontally stretched by a factor of 2. Okay, it's 1 by a factor of 1 over b, which is 1 over 1/2, which is equal to 2. So think about this. This got stretched. Now, because it's stretched, we're going to be looking for a solution where it's going to be, there's going to be less solutions than it should be in every 2 pi. So let's take a look. We'll see what that looks like. So what we're going to do is we're going to put all of the, first, we're going to let a different variable. We're going to, instead of saying 1/2 x, we're going to say let y, no, that's not a good idea. Let's just go theta. Okay, let theta is equals to 1/2 x. Okay, so that actually simplifies things. We're not looking at the whole thing, but we're just looking at um, you know renaming 1/2 x with just theta. So what does that look like? So if we rewrite that, that's going to be 3 cos theta minus root of 2 equals to 5 cos theta. And that's about it. So when we look at this part in here, how do we solve for this kind of, so now it looks like a one variable equation, right? It looks like a one variable trig equation, just like what we had previous in the previous examples. So I'm going to put the cos theta on one side and then the number on the other side. So what does that look like? So 3 cos theta. Now bring this there. So negative 5 cos theta equals 2. And I take this negative root of 2, take it to the other side of the equation. It's going to be root of 2. We can simplify that. So 3 cos theta minus 5 cos theta. It's going to be negative 2 cos theta equals to root of 2. And then I got to take a look. Okay, cos theta is equals to root 2 over negative 2. So you can say negative root 2 over 2. Now, at this particular stage, we should recognize, hey, root 2 over 2 is a special angle. So what are we going to do? What are we going to do? We have to look, okay, where is cos negative? So cos is negative. Okay, cos theta is negative in quadrants 2, 2 and 3. 2 and 3. Okay, in quadrants 2 and 3. Okay, so if that's the case, we're going to take a look at the reference angle. So, okay, let's find reference angle first. And you probably already know this. So if we want to do the reference angle, we're going to go cos theta. We're just going to go root 2 over 2. So that makes it both positive. So that, okay. So cos theta. And then you'll find that reference angle, that's going to be 45 degrees. 45 degrees. So what does that look like? So we know cos of theta is a negative root 2 over 2. So it's going to be in quadrants there, in 2, in quadrant 3. We figured out the reference angle of 45 degrees. So that means this is 45 degrees and 45 degrees. So that means theta in quadrant 2, it should be 180 minus 45. Theta is equals to 180 minus 45. So theta is equals to 135 degrees. And then in quadrant 3, okay, theta is going to be 180 plus 45, which is that's going to be 225 degrees. Okay, so in this particular case, we thought that, hey, we found the answer, but not quite yet. Not quite yet, because remember, theta is not the variable here. It's the variable x. So what we're going to do is we're going to put back this part over here. So we're going to put back 1/2 x and replace the theta. So we're going to put back, replace again, put it back. So we know theta is going to be 1/2 x is equals to 135 degrees. And then, of course, we're going to solve for x, so cross multiply that. X is equals to 135 times 2. That's going to be 270 degrees. 270 degrees. So x there is 270 degrees. Well, what about this one in here? We're going to replace the theta by 1/2 x. So replace it with x again. So 225 degrees. And then we're going to cross multiply this so that x is equals to x times 225. So that's going to be 450 degrees. 450 degrees. So it looks like we have two solutions, right? In this particular case. But look at this one here. Our solution has to be found between 0 and 360. So that means this is in the domain. So that one works with, that's a solution within the domain. But this one here, this is outside the domain. So this is a correct solution if we didn't have the domain, but because we have a restricted domain, this is going to be not part of the domain. So we're not going to consider that as our solution. So what are we going to do? Let's check our answer. Okay, it's nice to check our answer. Check or verify. Verify our answer. So what's our answer? Our answer is x is equals to 270 degrees. Yes. So we're going to set up the left and the right side. We've got lots of room here to do this. So the left side and then the right side. So the left side says here 3 cos of 1/2 times x, which is 270, minus root of 2, okay, whatever that is. And then on the right side, it's cos, oops, forgot the 5. 5 cos of 1/2 times x. Okay, x is 270 degrees, so let's put that there. Okay, so now what are we going to do? We're going to work this out and see if our answers is in the left side and the right side are equal to each other, then that means our answer is correct. So this is going to be 3 times cos of what's 1/2 of 270. It's going to be 135. So it's going to be cos of 135 degrees minus root of 2. You know what? We can figure this out. So it's going to be 130 cos of 135 degrees. We can just do our calculator here. Or we could also do the exact value. So 135 degrees is right in here. This is going to be 135 degrees. Cos is going to be negative root 2 over 2. Okay, so negative root 2 over 2, root 2 over 2. So the cos is going to be negative root 2 over 2. So it's going to be 3 times negative root 2 over 2 minus root of 2. So that's going to give us negative 3 root of 2 over 2 minus root of 2. Okay, well, this makes it, we have to solve this and say, okay, before we add these two, we have to have the same denominator. So this becomes negative 3 root of 2 over 2 minus 2 root of 2 over 2. So I'm multiplying both the numerator and denominator by 2 over 2. So now that they have the same denominator, I can go as negative 5 root of 2 over 2. Negative 5 root 2 over 2. Okay, so that's my answer. Let's figure this out. What's 5 times cos of a half? Cos of 1/2 times 270. So this is going to be 5 times cos of 2 times 1, 2 times 2, 1/2 times 270 is going to be 135. Okay, so what is the cos of 135? Well, cos of 135 is negative root 2 over 2. Okay, and we're supposed to multiply that by 5. So 5 times negative root 2 over 2, that's going to be negative 5 root 2 over 2, which is the left side is equals to the right side. So that means our answer is correct. Okay, now this is not part of the question, but if we were to find the general solution, okay, because you might be asked, what is the general solution for this one? Okay, so I'm just going to go over here. General solution. Well, we have to first figure out the period. What is the general solution? Okay, I know it's not part of the question, but in the book, they ask you that. So let's do that. Well, what's a period? Period is going to be 2 pi over b. Now, if this is a function, your b value is 1/2. 1/2. So the period, is 2 pi over 1/2. Okay, now I'm operating here with 2 pi. That's going to be 360 over 1/2. Okay, so just remember that this is going to be an angle is degrees, not radians. So therefore, period is going to be every 720 degrees. Every 720 degrees. So we have two possible solutions, right? And then the period is going to be 270 degrees. So that means x is equals to 270 degrees, of course, plus 720 degrees times k, where k is an element of the integer. That's one solution. And then the other solution is x is equals to, remember, if this is a general solution, that means we're going to consider everything. So 450, right? That's this one here. Plus the period is 720 degrees times k, where k is an element of the integer. Okay, so just to show that to everybody. Okay, that's good. We did pretty good. We did the solving of trigonometric equation involving multiple angles or half angles in this case here. All of these notes are going to be on the blog, so if you didn't catch everything, it will be there. Now we're going to go to the next page, which is page 7. Okay, so here we go. In page 7, example 6, this time we're going to talk about second degree trigonometric equation. So second degree, when we talk about second degree, we're thinking of a quadratic trig equation. Okay, so quadratic trig equation. So what does that look like? Um, Now, because we're talking about quadratic trig equation, you might have to do some factoring. Okay, so let's see how that goes. So solve the equation of 4 sine squared of x is equals to 3. Okay, that's kind of interesting because this is now the quadratic. Okay, sine squared of x. So second degree because it's a degree 2. What does that look like? What we're going to do is we're going to go 4 sine squared of x equals to 3. We're going to solve for x. So how do we do that? Divide both sides by 4. So that one's easy. So sine squared of x equals to 3/4. And then we have to get rid of the square. Okay, so sine squared of x. Sine squared of x means, I want to write this down first. Sine squared of x means sine of x squared. Okay, it's not x squared, but the sine squared of x. So from here, we can just, to get rid of the square, so you got to take the square root, take the square root. So sine of x is equals to, now if I take the square root of 3/4, this is going to give us plus and minus value, right? So plus and minus root 3 over 2. Okay, now you see root 3 over 2, you're probably thinking, I recognize that as a special angle. Okay, so where is sine of x positive root 3 over 2 or negative root 3 over 2? So we have to consider both. Okay, I'm gonna draw the unit circle. I like drawing the unit circle because I like the visual part of it. So sine, we're gonna have to solve for where sine is positive root 3 over 2. So two possible solutions. So sine of x is positive root 3 over 2. So that happens in quadrants 1 and quadrant 2. Okay, so this is in quadrant 1 and quadrant 2. And then the sine of x is equals to negative root 3 over 2. Well, that's going to be in quadrant 3 and quadrant 4. So we have quadrant there and there. So let's figure out the reference angle here. So sine of x is root 3 over 2. Reference angle is going to be pi by 3. So this is going to be pi by 3 reference angle, pi by 3, pi by 3 reference angles. Okay, I'll just put that down here. Reference angle is equals to pi by 3. So therefore, the solutions are, okay, I'm going to go here. Therefore, we have solutions. The solutions are, so from here to here, that's pi by 3 in quadrant 1. X is equals to pi by 3. In quadrant 2, I'll just go by quadrants. Quadrant 2, it's going to be x is equals to pi minus pi by 3, pi minus pi by 3, which is 2 pi by 3, and we know that. In quadrant 3, 3. Okay. Just erase that piece. In quadrant 3, it's going to be pi plus pi by 3. Pi plus pi by 3. So that's going to be 3/3 of a pi plus 1/3 of a pi. So that's going to be 4 pi by 3. 4 pi by 3. And then in quadrant 4, it's going to be all the way 2 pi minus pi by 3. So that's going to be 6 pi over 3 minus 2 pi. So it's 5 pi by 3. Okay. So in this particular case, we have lots of solutions. We have 4 solutions. And these are the solutions. Okay. And all of these are within the domain 0 to 2 pi. Pi by 3 is right here. 2 pi by 3 is right there. 4 pi by 3 is this one. And then 5 pi by 3 is this one. Okay, and then all of that is within 0 to 2 pi. Okay, so let's give the next one a try. Solve the equation 2 cos squared theta minus 3 cos theta equals to 0 over the interval between 0 to 360. Okay, so this is going to be from 0 to 360. The angles are expressed in degrees, so my solution has to be in degrees. How do we do this one here? Well, we have cos squared theta and then the cos theta. So what can we do? What can we do? Here's something that I could show you, and it helps some people. Some people don't need it. It depends on you, right? So what we could do is we can figure this out here. We can let cos theta equals to x. Instead of cos squared theta, you can just put x for now. Okay, so like I said, actually, I'm gonna solve it without it and then I'll solve it with it. Back up. Okay, I'll solve it without it and then you can compare. So 2 cos squared theta minus root 3 cos theta equals to 0. So what we could do in here, we can see that there is a common factor of cos theta here. Okay, so the common factor of cos theta, so factor out the cos theta. And once we factor out the cos theta, we're left with 2 cos theta minus root of 3 equals to 0. So we have 2 possible solutions. It's either the cos of theta is equals to 0 or 2 cos of theta minus root of 3 is equals to 0. So let's see that. Where is cosine? Cos theta is equals to 0 degrees. Well, where is cos 0? It's going to be, here's a visual. I'll do the visual here. Cos is 0 at here at 90 degrees and 270. So that's going to be 90 degrees and 270 degrees. Okay. Now for this part over here, 2 cos theta minus root of 3 is equals to 0. So solve this out. So cos theta is equals to root 3 over 2. Okay, now we have to look, well, where is cosine root 3 over 2? Root 3 over 2, that's a special angle right there. in quadrant 1 and right here in quadrant 2. So these are the places where it's going to be cosine is going to be root 3 over 2. So what angles are those? That's going to be theta is at 30 degrees. And then over here is 330 degrees. Okay, so these are our four solutions. So therefore, these are the solutions. And all of these are within the domain of 0 to 360. What we're going to do, we won't be able to verify everything, but here's what we could do. Okay, I'll show it to you I'll show you one of them. Okay, so we can go verify. I'm going to verify left side has to equal to the right side. I'll do only one so that you can try the other ones if you want. I'm going to do theta is equals to 90 degrees. Okay, so that's going to be 2 times cos squared of 90 degrees minus root of 3 cos 90. And then the right side is going to be 0. So if this one has to be 0 to see if our answer is correct. Okay. So 2 cos squared of 90. So what we're doing here is 2 cos squared of 90 means cos of 90 times cos of 90. Okay, so cos squared of 90 means cos of 90 times cos of 90. I'll just write that down. Cos 90 all squared minus root of 3 cos 90. Okay, well, what's cos of 90? Well, cos of 90 is 0. So 2 times 0 squared minus root of 3 times 0. So 2 times 0 squared is 0 minus root of 3 times 0 is 0. So therefore, 0 equals to 0. Our answer is correct. Okay. Now I'm going to pick something from here. Okay. I'll show you how to do that on a calculator. So make sure that your calculator is degree. Okay, so you go 2 times cos squared, cos wherever your squared is, of 30 degrees minus square root of 3 cos of 30 degrees. Oh, I don't think my calculator could do that. Okay, I would have to do it this way. I have to do it this way. Sorry about that. So 2 cos, you see here, cos squared of 30 degrees. So I'm going to go cos 30 and then I square it after. Okay, so cos squared of 30 means cos of 30 squared minus root of 3 cos of 30. I don't think my calculator could do that. I'm not sure if your calculator could do that. So I'm going to try it again. 2 times cos of 30 all squared minus square root of 3 cos of 30 degrees. I'm going to get a 0 on this side, and then the right side is 0. Okay, so I don't know if your calculator could do the cos squared of 30, but mine can't. So I had to do cos 30 and then all squared. Okay, so that's a possibility. Okay, let's just do a quick check to see if your answer is correct. If you have any questions, send me an email, and we could arrange for a Google Meet. If you want to talk face to face, and if you can't, let's take a look at letter C. How are we doing here? Oh, yeah, we're okay. Sine squared of theta minus sine theta equals 2 for 0 to 2 pi now. Okay, now we're back to pi's. Okay, so sine squared theta minus, okay, I just want to say sine squared theta really means sine theta all squared minus sine theta equals to 2. Okay, so in this particular case, you're going to see that there's going to be a quadratic, degree 2. So how do we do this? We can't just factor it out. We bring this one to the other side. So sine squared theta. So sine theta all squared minus sine theta minus 2 equals 0. And then this is the one that I was actually talking about earlier, where it would be nice to rewrite this. So let's rewrite it as this, and then you'll see it very clearly. We're gonna let x is equals to sine theta. Okay, so if we let x equals to sine theta, then what does that look like? Sine theta squared will become x squared minus, well, sine theta, I'm going to put minus x minus 2 equals to 0. So having, now that we've gotten rid of sine theta and we just kind of replace it with x, this becomes something easier to factor out. So what can we do? Well, how do we factor a quadratic? X squared, that's going to be coming from x times x, and I'm going to have a negative 2, so it's going to be negative 2 plus 1. So after we factored it out, it becomes x minus 2 times x plus 1. And now put it back, put the sine theta back. Okay, so instead of x, we're going to put sine theta minus 2 times sine theta plus 1. Okay, so now what we're going to do is we're going to go here. So sine theta is equals to sine theta minus 2 equals to 0. That means sine of theta is equals to 2. Now, if we take a sine inverse of that, this is actually outside the unit circle. We won't have a sine of theta equal to 2. Okay, so theta, no solution. Okay, so you can go here on our calculator, solve for theta. If you don't, if you're not sure, you can go, okay, how do I solve for theta? I take the sine inverse of both sides. So I go sine inverse of 2, and then you're going to get an error. Okay, no solution there. And then now, what about this one? Where is sine theta? Sine theta plus 1 equals to 0. So sine theta is equals to negative 1. Where is sine negative 1? Exactly negative 1. So that's part of a unit circle. Special angle, sine is negative 1 right here. Okay, so what angle is that? So that's going to be 200 and, oh, okay, now I got to go back because this is the angle is in radian. So that means that part is 3 pi halves. 3 pi halves radian. Okay, so let's verify that. There's only one solution so that we can do verify. Verify. Okay, so we need to do the left side and we need to do the right side. We're going to verify theta is equals to 3 pi by 2. So that means sine of 3 pi by 2. Okay, whatever that is, I'm going to square it. So that's what that means. Sine squared of theta minus sine of 3 pi by 2 equals to 2. Okay, let's see here. What's sine of 3 pi by 2? Sine of 3 pi by 2 is going to be negative 1. So negative 1 squared minus, what's the sine of 3 pi by 2? It's another negative 1. Negative 1 squared is 1. Negative times negative is a positive 1. So that's equal to 2. So now, as you can see, left side is equals to 2. Right side equals to 2. So that means left side is equals to the right side. Okay, and that's a solution within within our 2 pi, 0 to 2 pi. Okay, here we go. We're on the last equation, last one. And this one is going to be interesting. Solving a second degree trigonometric equation using quadratic. Okay, they're already telling us with the strategy. Okay, let's pretend we didn't know how to do that one yet. So solve the 4 tan squared of x equals 2 tan of x plus 1 equal for the domain of 0 to 2 pi. Then state the general solution. Okay, that's where the general solution is. Okay, so what can we do? What can we do? 4 tan squared of x. Okay, so what we can do is we can say 4 tan squared of x means tan of x squared. Okay, all squared. The x is not squared, but the tan of x is squared, all of it, equals to 2 times tan of x plus 1. Just like what we did previously, what we can do is we can bring everything on the, because this is a quadratic equation, we're going to bring everything on one side of the equation. That becomes 4 brackets tan of x squared minus 2 tan of x minus 1 equals to 0. Okay, so if you want, what you could do is we can let y equals to tan of x. Okay, so that's will make our equation a little bit simpler. So it becomes 4y squared. So we're going to replace tan of x with y. So that's going to be y squared minus 2 times y minus 1 equals to 0. Now, in this particular case, we can't really just factor it the way it is right now, because this is going to be 4, and then this is 1. Any factors that will add up to 2, we don't have anything. So what we can do is we could solve using a quadratic formula. So this is not an easily factorable quadratic equation. So how do we use our quadratic formula for that? because we're solving for y, so I'm just going to put y in here. Negative b plus or minus root of divided by 2 times a. Okay, so a is 4, b is negative 2, c is negative 1. So this using of quadratic formula, we learned that in grade 11 pre-cal. So let's figure that out. So negative b, so negative 2, so that's going to be negative 2 plus or minus root of b squared. So negative 2 squared minus 4, a is 4, c is negative 1, divided by 2 times a, so it's 2 times 4. And of course, we can simplify that. We can work it out. So that becomes 2 plus or minus root of, let's see what this is. It's going to be 4 plus 16. So that's root of 20 over 8. Okay. So if you want, we can simplify this. Certainly, we can simplify this. It's going to be 2 plus or minus square root of 20. That's the same thing as square root of 4 times square root of 5. So it's going to be 2 root 5 over 8. And then factor both, common factor of 2. So it's going to be 1 plus or minus root of 5 over 8. And then the 2 and the 8 has a common factor of 4. So that becomes y equals to 1 plus or minus root of 5 over 4, which is kind of like a really not a nice number. It's going to be an irrational number. So what we need to do is put that information back. Okay, so we're going to go back up here. Okay, where our equation doesn't have y, our equation has tan of x. So we're going to go back and see. Okay, so that means our tan of x is equal to, okay, remember, the y is tan of x, so we're going to replace the tan of x back. Okay, so instead of y, we're going back to tan of x. Tan of x is equals to 1 plus root of 5 over 4. So that's whatever that solution is. And then we have to look, okay, where is tan positive? Where is tan positive? Tan is positive in quadrant 1 and quadrant 3. So tan of x is equals to some kind of a positive number. Brackets 1 plus square root of 5 divided by 4. So it's positive 0.8091. Okay, so it's tan is positive in quadrant 1 and 3. Okay, so because this is already quadrant 1, we can just go x is equals to the tan inverse of this number. Keep as many decimals as possible for sure. So tan inverse that. Uh-oh. I have a degree. Okay, back up. Okay. They keep switching back and forth from between angles like degree and radian. So I gotta make sure that my angle is radian. So let's back up again. So I do this one here. Brackets 1 plus square root of 5 divided by 4. So it's the same thing. And then I'm going to do the tan inverse of that. So this is the reference angle, 0.68 radians. Okay, so 0.68 radians. So it's tan is positive in quadrants 1 and 4. And because we just took the positive value, we do the reference angle of 0.68. And then this is 0.68. With the tangent, we learned before that the period is going to be pi radians. So period for tan is pi radians. So in this particular case, the general solution for this is x equals to 0.68 plus pi times k, where k is an element of the integer. Okay, so this is only for the solution in quadrant 1 and quadrant 3. So if I add pi, then I'm going to go to this quadrant 3 here. Okay, so that's that part. That's for tan of 1 plus root of 5 over 4. Now, what about the other one? I'm going to go back. Tan of x is equals to 1 minus root of 5 over 4. Okay, so just to kind of refresh our memory, this is our solution earlier. We're replacing y back with tan. So we did the 1 plus root of 5 over 4. Then the next one would be 1 minus root of 5 over 4. Okay, so tan of x is equals to, let's figure that out, 1 minus root of 5 divided by 4. It's going to give us negative 0.0390. Okay, a whole bunch of digits. So how do we figure out the x? We're going to take the tan inverse of that. Should be no zero there. 0.3090. A whole bunch of digits. Okay. I'm showing all of the steps so that when you go back and read your notes, I am hoping that you are able to follow along and I'm not skipping steps in here. So to solve for x, I have to take the tan inverse of both sides. So the tan is gone. Now I got to do the tan inverse of that. So it's going to be negative. Oh, okay. So this one in here, if I want to do the reference angle, I'm going to put the reference angle, tan inverse of 0.3090. Okay. The reason why I had to do the tan inverse of a positive is because I want to do a reference angle. And why do I need a reference angle? Let's see here. We said that the tan of this value is some negative number. So because this is a negative number, where is tan negative? Tan negative is negative in quadrants 2 and quadrant 4. So if we figure out the reference angle, then I could get that reference angle there. Okay. So I'm going to just do the positive so that my reference angle, I don't have to worry about some negative values there. So tan inverse of 0.3090. Reference number is 0.3. which is kind of nice. So therefore, x is equals to, if we wanted to do this part in here, pi minus 0.3 it's going to be 2.84 radians. And then this is going to be, so from here to here is going to be 2.84 from there. Now, if I go rotate again, pi radians this way, and now I'm going to hit this one. I'm going to be over here. And if I turn pi, then I'm going to reach this part. So from here, the general solution is x equals to 2.84 plus pi times k, where k is an element of the integer. Okay, and the reason why it's pi, because the period for 10, is pi radians. It repeats itself every pi radians. Okay, that's a quite intense one for sure. Quite a bit of stuff that we learned in that particular topic. So just to summarize, what we did is we solve multiple angle trig equation, or trig equation with multiple angle, and we also did the second degree trigonometric equation. So in this particular case, the practice questions for this one here, okay, the practice questions for that are, I wrote it down. Question So you're going to do question 9 through 14. Okay, so I'm hoping you did the question 4 to 8 last time. Now it's going to be for the new stuff that we talked about, question 9 to 14. Okay, question 9 to 14. Starting on page 595. The questions 4 through 8, I will post the answer key to that one. Okay, so I did the solutions to those questions. So I'm gonna start posting some of these solutions that I did, and then so that you can just go back and see what, verify your solution, and then yeah, so it should be good. Okay, I think I'm gonna stop right there. I'm gonna leave you with extra time to do some work. So thank you very much. I'd like to take this opportunity to thank you for participating and in joining our class for today. And if you have any questions, please let me know. Send me an email. I want to mention this again, that if you do not, if you can't express your question through email, schedule a Google Meet so we can like talk face to face, and then and see if it's better that way. Okay, so well, thank you, and I wish you a happy day, and I'll talk to you soon. Okay, bye for now.